In power distribution networks, it's important to have enough number of vias to accommodate the current transition. If there are less number of via than minimum required, the current density might become too high in the existing via and they might melt off and cause failure. Multiple via connecting the same layers can be modeled as parallel resistors, thus having more of them reduces the overall resistance. This rule checks number of vias at the layer transition area per specification. This rule needs to have constant voltage value nets such as power and ground nets in the design. It should be run on the nets that draw a lot of current at the same time, for example, nets in automotive and robotic applications. It uses the following parameters to detect a violation. Max via current is the maximum allowable current for a via. If the current passing through the via exceeds that value, the via will burn out. Max current is the maximum allowable current on the net. We can also define maximum current per net width for inner and outer layers. If max current specified is 0, then Hyperlink's DRC will use inner and outer layer per width current values to determine if sufficient number of vias are placed on the net or not. I will be using these parameter values to find violations. Let's run the rule and take a look at the violations. As we can see in the via count, the total number of via for each transition is only 1. To accommodate the 2 ampere current, we need to add 3 more via to the same transition. The layout engineer needs to go back and fix this issue. This way, Hyperlink's DRC catches power integrity issues with minimal setup and fast runtime.